So today we will see the Cohen-Sutherland line clipping algorithm. As I said that whenever you capture a picture through the camera, you have one rectangular frame on that lens, and whatever picture comes inside that particular frame, only that picture is displayed, and rest of the part which is outside of the window is always discarded. Okay, so now if you are drawing this on the paper with the pen and paper, so you will definitely erase the rest of the part with the eraser, or you will delete it from the paintbrush. But whenever we are dealing it in case of computer graphics, we have to, or we should have some algorithm to clip that particular part. Okay, so now if we want to delete a line which is going outside of that particular window, then we have one algorithm that is called as Cohen-Sutherland line clipping algorithm. Now this is especially used for line clipping. Okay, now the world space, as I told you that this is the world space we can consider in this diagram. This world space is always divided into 9 regions. So here you can notice the space, I'm saying this one. Okay, you can observe this diagram. Okay, so here this is the world space, consider, and I have divided, or we have divided this world space into 9 regions. So this is the first region, this is second region, we can say this is the third region, and so on. So fourth, then 5, 6, 7, 8, and 9. Okay, so there are 9 regions in the world. Okay, so now the region code, it is also called as the out code. Okay, this region code is also called as out code, and each region has a unique 4-bit region code, or the out code. Okay, now these are the 4 bits, say 0, 1, 2, 3 represents the 4 bits of that region code. Now the region code indicates the position of the regions with respect to the window. So this is the legend for that region code, and each code or each bit has some meaning. That is, bit 0 is assigned for the left window boundary, 1 is assigned for the right window boundary, 2 for below window boundary, and 3, this is assigned for the top or the above window boundary. Okay, now we know that this is our window. Now consider this rectangle, inner rectangle is your window, or you can consider this as the rectangular part which comes on the camera lens. So whatever will come in this particular region, only that will be taken, and rest of the part will be discarded. For example, if I draw this particular line, okay, in that case, only the part which has come, I can show you this with some different color. So the part which is inside of this rectangular window, so we can say this part only. So this much part will be displayed, and here this part will be discarded from whenever you run this line clipping algorithm. Okay, so only this much part should be displayed. Okay, so now we have to do all these things. So how it can be done? So as I said you that each region is assigned with some region code, and these are the bits or bit positions for that window. Okay, so how to assign this code? Now this is the first one, is the left window boundary. This second vertical line is the right window boundary, and this is the top or above window boundary, and this is the bottom window boundary. Now I will tell you for the first region, that is this region, and rest of the regions you have to identify. Okay, you calculate on your own. Now for the first region, I have to consider this code as the left, right, below, and above. So we will start from the third one first. Okay, so this is the sequence for that region code. So first case, first bit I'm finding this. From this direction we will move. Okay. So I will find out the first bit first. So above, whether the first bit, this region is above the window boundary. This is my window boundary, top boundary. I'm talking about this particular region, first region I'm talking. Okay. Now for the first bit, I'm saying that whether this area is above the window boundary. So yes, this is above window boundary. So I will set the bit of this particular region to 1. Okay. So this is because this is the on the upper side of this window boundary. I'm saying that yes, it is, this region is on the top. Now you can check this, that either of these two bits, that is top and below, either of this bit will be set to 1 and next will be definitely set to 0. Because if it is on the top hand side, it should not be on the below side, or if it is below the boundary, it should not be on the top. And same case for right and left. If it is on the right hand side, it should not be on the left, and vice versa. Okay. So now as this is on the top, below will be set to 0. Okay. By looking at this region, you can identify that this particular region is above, or it is top of this boundary. That's why this bit is set to 1, and it is not below of this boundary. So this is set to 0. Now again we will check for right. Okay. So for right, what we have to do? Again, we will check this particular region, whether this is on the right hand side of this window boundary. No, it is on the left hand side. First region is on the left hand side of this window boundary. That's why this bit will be set to again 0. Is it on the left hand side of the window boundary? Yes, it is on the left hand side of this boundary. That's why this bit will be set to 1. So now the region code for the first region I have identified as 1001. So we will check, yes, this is the correct code. Now we will go for the second region. Okay. For second region, again, we have to find out the same thing, whether this second region is on the top side. So yes, it is on the top side. So it is not on the below. So 1, this bit will be set to 1. Then for 0, then we will check for right. It is neither right nor left, because it is inside of this left and right boundary. So all these two bits will be set to 0. So what should be the code here? It should be 1 0 0 0. So this is the code 1000. Okay. Next is what? Again, this third region. It is on the top. Yes. So I will set the first bit to 1. So this is 1. Is it below? No. So it will be set to 0. It is on the right hand side of this boundary. Yes, it is on the right hand side. So this again bit will be set to 1. And if it is 1, left will be 0. So this code will be 1010, and so on. You can calculate the fourth region also. For fourth region, it is neither top nor bottom. Okay. So first two bits will be 0, but here it is not on the right hand side. It is 0. So on left, that's why it is 1. And the middle region, fifth region, is always set to 0000. So further you can calculate. The sixth region comes as 0010, 7th comes as 0101, 0100, and 0110. So these are the region codes for 9 regions. Okay. So these we are going to consider while studying this Cohen-Sutherland line clipping algorithm.